Here we will see application layer in clean architecture. The application layer is the central layer that bridges the user interface and the core business logic. It defines the system use cases that translates user action into operations on domain entities without knowing how the UI works or where the data is stored. In this layer, services interfaces are kept, which are separate from their implementation for loose coupling and separation of concerns. It strictly depends on inner domain layer while remaining completely decoupled from databases and frameworks. Application layer translates input from presentation layer into actions which are executed by the domain layer for managing workflow, validations and data transformation while remaining completely isolated from UI and database technologies. Some of the responsibilities of application layers are: first, implementing use cases. It houses application specific business rules and use cases that define exact capability of the software. Then workflow coordination. It directs the flow of data and commands, coordinates the domain entities and domain services to accomplish specific tasks. Then defining interfaces. It provides contracts for external concerns like databases, logging and third-party APIs so the system remains decoupled and testable. Then data transformation. It handles the mapping and translating of domain models to data transfer object for presentation layer to consume and vice versa. Then input validation. It performs boundary validations on incoming requests before they reach the domain models. And error handling. It manages application specific exceptions and error messaging. First is command, which represent actions for creating data, update data, delete data, which usually return success, failure and generated ID. Queries, which are used to retrieve data. The data returned from queries is read-only, that is, a query should never modify the data. Then command handler. Handlers contain the logic for processing commands and queries, which acts as the implementation of use cases. Then DTO, that is data transfer object. DTOs transfer data between layers. It prevents exposing domain entities, controls return data and improves security. Then application interface. Application layer defines contracts. Implementation resides in the infrastructure layer. So it supports dependency inversion principle. Then validators. It validates incoming requests before execution, often implemented using fluent validation, which ensures valid input before business processing. Then application service. Application services coordinate multiple operations. It plans business workflows. Then mapping components. It reduces manual conversion code. And use cases, which represents a business operation. Benefits of application layers are: workflow planning. It coordinates application specific tasks and workflows without polluting the domain layer with infrastructure concerns. Then decoupling. It keeps the core of the system flexible by depending on abstractions rather than concrete implementations. Then high testability. It allows developers to write fast isolated unit tests for workflows by easily mocking external dependencies. Then maintainability and adaptability. It simplifies the process of swapping out technical frameworks, databases or UI clients without modifying business logic. There are some drawbacks of application layer. First, pass-through use cases. For basic CRUD application layer use cases act as a wrapper that pass data straight from the presentation or API layer to the data layer. Massive file counts. Adding a simple feature may require creating multiple files, that is, a request DTO, response DTO, interface, handler and dependency injection mappings. Then scattered feature files. Since code is separated by architectural layer rather than features, related logic is spread across different directories. Then cumbersome refactoring. A change to a single business requirement often forces developers to traverse and edit 3 to 4 different layers. Then framework leakage. The application layer depends on interfaces to communicate with outside world. Managing exactly what belongs in the application layer versus the infrastructure layer can easily blur and violate decoupling rules and unnecessary overheads. For small application or prototypes, these layers added complexity, drastically reduce the development speed and increase the initial setup time.